I'm very delighted being here presenting for Java Meets AI, an introduction for Spring developers. So when I had been at several conferences in the past year, so we're doing this session for like a year almost now, it came out that like most of the people haven't tried out AI in Java yet. So did you already try out Java and AI? Oh, okay, maybe a bit different. Thanks for being here nevertheless. My name is Sandra Ahlgrimm. I'm a cloud developer advocate working for Microsoft or for Java at Microsoft. And I'm here with Timo, whom I invited as a special guest. Sorry, he wasn't here before. He had a different appointment first, but yeah, super happy they're customers.
I made it.
Rescheduled.
I'm a research specialist at Broadcom, so the vendor of Spring. So we have most of the paid actually contributors to the Spring framework. We were acquired 2 times, so I joined Pivotal, acquired by VMware, now Broadcom. And yeah, my focus is really on helping our customers with Spring platforms and data, and for sure also our commercial Spring products. So
okay.
Yeah, for today.
Let's start with some fundamentals first. Just very briefly, very quick, what is Gen AI and why do we talk about Spring? And then we will get into some demos. We have some simple demos, then some more advanced demos with the real coded example. Everything is on GitHub. We will also share the URLs with you so you can easily compare the code. We implemented basically the same backend 3 times. So we will only show the UI once because, you know, it always looks the same, but we have the backend 3 times so you can actually compare the code, how it would look like in all 3 frameworks that we're having here. So to set the stage, AI, super new thing, came out in the 60s, basically in movies where it was first introduced as roboters being actually able to think as a human, right? And then in the centuries after, it defined even more with machine learning and deep learning. So you had the specialists, the data scientists, doing all the hard work for us Java developers of actually training models with like a huge amount of data, and then very specific for like each domain, they trained the data. Then with foundation models, we were actually able to get this data into like context and to actually use different kind of domains together. And then we have now the large language models, which are actually able to understand human language and then to also get the data back as human language like. So that's like the main thing to set the stage here. And when we talk about LLM and using LLMs, there's basically this main concept important. So we need to know what is a prompt and what is a token. So a prompt is like a system or user prompt. So in this case, it's basically what I give into the LLM. So here it is, for instance, Berlin is. You can see here the tokens. It can be a word, but it can also be just a part of the word, so a substring or a specific number of characters that depends on the large language model, right? And the LLM or SLM will always just give me the next token, which is more likely. So here I can specify a bit of creativity or similarity index or however it is called in which framework. But basically it will give me like, so I give it into my LLM, I send Berlin is, and then it gives me vibrant, diverse, or innovative. When I be like very specific, it will always give me, or mostly always give me vibrant. It's non-deterministic, I can't rely on it. And it will also not check if the whole sentence makes sense, right? So it will always just give me the next token. It doesn't make any, like we humans would do, right? We always think, is the sentence grammatically correct or something like that? Or is like the whole thing, does it make sense? It's usually not what an LLM does. It will just give me the next token, which is more likely. The way it is trained, it usually does make sense, but still, we always need to keep in mind when we work with LLMs that there's no further checks attached. So after I set this stage here, Timo, why would we focus on Spring?
So actually, it's like all the samples we built, they are based on the Spring framework. So we can for sure use those different AI frameworks that we will introduce, but we're using the Spring framework here. Not only because we are the vendor of it, so Broadcom, also because like the majority of the developers on the JVM are using Spring as a framework, because at the end, especially with Spring Boot, it provides a lot of like speed, product develop productivity and integrations in all common databases, solutions, etc. So it really helps you to focus on business code and not too much about integrating solutions. If we have a closer look at AI frameworks in general and also Java AI frameworks, so why do we need those frameworks? At the end, it's like most of the models we know and we want to consume, they are provided by AI providers, which are actually providing APIs, mostly REST APIs, to interact with the model. So at the end, it's like they are just REST calls. So if I want to use OpenAI in my Java application or the Python application, I just do a REST call to this API, and I will get back the response. So we can see a sample here based on the Java HTTP client. That's possible for sure. The thing is that regarding those interactions and the context, so this the prompt you actually send to the LLM, there's a lot more to do. And to simplify that, all those frameworks, they provide abstractions, so high abstractions, where you can then really just focus on, okay, what's my business problem, the question I'd like to get answered, and have productivity features like, for example, structured output, that you can directly convert like the response into a business object. So what those frameworks will do, they will, for example, add to the context a JSON schema, instruct automatically the large language model to send back JSON so that it can also automatically actually map that to a business object. So that's one example. Also things like chat memory. Vector store support, etc. So really those higher abstractions so that you don't have to care about the basics. They also support advanced patterns because at the end it's like the context is limited of large language models. This means that you only can send a number of tokens, and every token is usually costs money to the large language model. So you have to enhance this context with information and also maybe strip it down to like the most important information you want to send to the large language model so that it can send you a relevant answer. Last but not least, and this is the reason why we talk about Java AI frameworks, in the past, the main language used for machine learning, etc., was Python. But I guess because you're attending this conference, you're Java developers, and you don't want to switch to Python and learn Python just to integrate large language models. For sure, for training them, etc. Most probably you have to learn JSON, but Python. But if you want to use those different models from AI providers, or also provided some from some machine learning engineers in your company, you can also nowadays do that in Java. And this is really the value of those Java AI frameworks. If we have a closer look at the frameworks we want to talk about today, the first one is LangChain4j. I think it's the first model, the first framework, AI framework for Java that was initiated in early 2023. A lot of those other frameworks, like also Spring AI, they were influenced by that. And the big benefit of LangChain4j is that it's framework agnostic and provides really integrations into Spring, into also Micronaut, Quarkus, etc. So it makes it as easy as possible to get started for those kind of framework developers. Spring AI is an official Spring project, and at the end it's also initiated in 2023, but a little bit later than LangChain4j. The big benefit of it, it really aligns with Spring core concepts, etc. So it makes it feel really natural. It's supported from Spring Boot 3.4. So for everybody that's still using Spring Boot 2.7 or 3.0, so all those releases that are out of open source support, it's now the chance to actually upgrade to get to those latest and greatest features. It has enterprise support in comparison to LangChain4j, so from us, from Broadcom. And then we have, last but not least, Semantic Kernel as an example. So that's a cross-platform framework from Microsoft, available for Python, C#, and also Java. The Java support is evolving, which means that it's not yet that feature-rich, but it's getting better and better. And it's also framework agnostic. So we have two frameworks that are framework agnostic, and one Spring AI, which is really focused on Spring only. And yeah, for Semantic Kernel, there's also enterprise support available. So let's have a look at the sample we actually built with all those three frameworks. Sandra?
Yes, I do the samples. So here's the website. We just started on localhost. So here's my recipe finder. So I love to eat, right? I don't like to cook. So I really need a recipe. I can't cook otherwise. So here I can, for instance, search for something cheese. And I'm also if if I do the, like, thinking about what to cook, we will always eat the same 5 menus, which is okay for my kids because they're totally into noodles, but really not okay for myself and also my husband. So this one will give me a very nice recipe. We're using OpenAI here, GPT-4o for the recipe, and also DALL-E 3 for the image. And here I already ran the request. So here you can see I get a nice picture, and also my recipe with the ingredients, instructions come out of it very nicely. Also the new just done request is ready here. So just another one. You can see here, it's actually cool that it is somewhat creative, right? So I don't have the same recipes over and over again. So it will give me something nice. So let's see how I can do this in code. Or first, how would I do this in LangChain4j? So it comes with a high abstraction of the AI service, and then with more focused or more low-level abstractions, such as the chat model and the image model. So here we can see, for instance, the AI service with the annotations, or also above that the image model. It potentially does make more sense if I show you in the real code. So for the app, we first needed to always put in the dependencies in the Gradle file or in the pom.xml, it doesn't matter. So as you can see here, we do have some Spring Boot starters also available for LangChain4j, which is always important if you want auto configuration. So here it is for, like, in general, but also for the different LLMs I'm using. And you might also already be seeing that some features don't have a good Spring Boot starter integration. So that's something everyone can work on since it's a community-driven project. And yeah, and then I can have a look at my properties files or application YAMLs, where we can here configure the provider configuration with the base URL for like local runnings. Or also if I deploy to Azure, for instance, I can also set here environment variables with the API key, set others for the image model, for instance, here. Use also different models for the different aspects. In code, I here have the recipe service. So we implemented it in 2 ways. So the first one is without annotations to make it easier for instance, non-Spring developers who might found the room as well. And then we also have the ones with the annotations. So here without, you can see how we are getting the, how we have nice template support for the prompts. So we're just getting it here. And it can be in another file. And this file, what I like about it, it doesn't have to be a code file, right? It can be just a simple text file, could be even in another repository. So for the whole prompt engineering, I can give that to another person who doesn't have to be a coder, who can do the prompt engineering work. And here you can also see how you would use it within your code. So you can actually give it other like values. Okay, so here we have the templates, and then you can see here how we use the highest level abstraction, build it with the system prompt, call the chat model. Yeah, and here we specify the ingredients out of the text box, as you have seen, and here it's then calling the recipe AI service with my message. What we needed to achieve that was also here the interface. So without annotations, you need to do that. With annotations, it would basically look like this one, so much shorter. I can give it the chat model, and then here make use of the annotations to retrieve the prompts.
And actually, so those were the high-level abstractions. So just like via these interfaces, and then you can make it via code, create an instance of that, or let the bean automatically be created and registered for you. But there's also this low-level API, as mentioned, for chat model and image model. So maybe you can also show like the image model.
Oh, yes.
How that looks like, because for image models, usually don't have that complex creation of prompts, etc. And therefore, usually it's a little bit more limited, and you don't need a more or a higher API for that. So it's enough to have a low-level API.
Totally. So for the image model here, I will use the lower level API, and then here also take the prompt templating support, and then also give it the recipe so it can generate a nice image for that recipe and then here I retrieve the generated image URL, and that's it. I like the fact that it comes with structured output in place. So here, because I define here the recipe, it already knows that I want a recipe back. So I could have also taken a string back, then it wouldn't answer with structured output, but we already have that in place here.
Yeah. And actually, it's like, so by defining this in the interface, all this, I need a JSON schema in my request to the large language model that it knows what to return, like an object in JSON in our form of the recipe. That's something automatically done for you. So on those lower abstractions, you have to do that manually. So there are also ways to define the schema in Java. But actually, it's like that's something in the high abstraction you don't have to care about. You just define, I want to have a recipe, and that the conversion into a schema and also back from the JSON into the object will be automatically done for you.
So Timo, how would you do that with Spring AI?
So actually, it's like I already mentioned that Spring, because it was initiated a little bit later than Lang4j, was actually influenced by it. And therefore, some of the abstractions, etc., you will see there, they are very similar. So like chat model, image model, those are the low-level APIs as available with Lang4j. But we also have a higher abstraction. The high abstraction is called the chat client, and that's really a fluent API. So you may know that from the Spring world with builders, where you just like have this builder and add all the configurations step by step. That's also something we used here for the chat client. There's another really important concept, which is called an advisor. I already mentioned that actually at the end, all these interactions with large language model or Gen AI models, usually they are just REST calls, so REST API calls. And what those advisors do, they actually inject into those requests. So for example, adding additional information to the context before it gets sent to the large language model, or also then adding additional functionality if the response is getting back to the client. And with that, we will later see more advanced patterns that are implemented with that. But you could also think about logging. So I want to log my request to the large language model or the context, and I want to log the response back. So you can really, in a way, inject additional capabilities into this flow of calling the large language model and the responses. If we have a look at the demo, so how that looks like or compares, at the end, it's very similar. So we first have like this the starters. So for all of the different capabilities, there are starters available, also those models. You see in our example, we are using 3 different AI providers. That's something you could do. Maybe for specific capabilities, it makes sense, or maybe also like if you want to do local testing versus production testing, so using a local model for your integration tasks, and then later for production, OpenAI or something like that, so a more advanced model. But here it's really for you to choose like the AI provider that you prefer and that you have access to. At the end, what we have with Spring AI, it makes it really easy for you compared to Lang4j to decide which AI provider you would like to use. So just via configuration properties, you can see with this Spring AI model for the chat, I would like to have Llama. For embedding, I would like to have Llama, and for all those others capabilities like image, audio, etc., I don't want to have a model yet, so it will not be auto-configured. So it's really you control the auto-configuration here. And then you have this AI provider configuration, as you also saw with Lang4j, where you can define the actual model you want to use, also the temperature. That's how deterministic or not deterministic actually the large language model is behaving. For Azure, we are just like defining, okay, please make the auto configuration for chat for the chat embedding an image model with Azure OpenAI provider, and also have our configuration. Let's have a look at the implementation. So at the end, it's like this low abstraction looks really similar. So there's not too much difference. We have the image prompt, all the tools to create this prompt, also with variables. And then we call it, we get back a so-called image generation and can get the URL. We could download like the image with that if we want to have it local in a way, or provide it with our API. Or in this case, we are directly just using the URL provided by the large language model. If you have a look at the chat client, everything is auto-configured for you. Despite the chat client, so there's a builder to actually add advanced configurations. For the use, so you can see we inject this chat builder, which is auto-configured. And in this case, we are setting a default system prompt. So you can set default prompts, like, for example, here, enhancing the results from the large language model. Things like, okay, please always answer in English, or some special hints regarding JSON. That could be done here in the so-called system prompt. And we are then injecting this chat client. And from the experience, you can see we are starting the interaction with the model with the chat client.prompt. And then providing the user prompt with also this templating support built in. We call it, and based on this configuration, we also enable the structured output. So yeah, that's it for Spring AI. So similar experience, different or way how this high abstraction is actually implemented. And yeah, great support for auto configuration, etc. Last but not least, we have Semantic Kernel.
Yeah, so for Semantic Kernel, we put the kernel in the center. It works as a
dependency injection. Yep, sorry.
Thank you. It works as a dependency injection container, and it is supposed to manage all AI capabilities and also other services and plugins. So in Idea World, it would be very easy to integrate with this one. Also, like if it would be in another repository in an Idea World. And in code, because that might be easier to understand. Okay, so first we start with adding the starters. Unfortunately, we miss a bit of Spring Boot starter here. So there is an example that I wrote, but yeah, as there is no Spring Boot starter available for the Semantic Kernel API, we need to take care of the auto configuration ourselves. So if you are, as a Spring developer, ever on this position, you will need to write something like that, where you here retrieve again the keys and everything from my properties or the application YAMLs, and then I can specify the beans. And so I will have to do that manually if there is no Spring Boot starter available. So that's what we had to do. A little bit of extra pain here, if I would say it like that. But then that enables me to go as it would have had a Spring Boot starter, and then also again use it the same way as we have seen it with Spring AI and LangChain4j, where I can select here the endpoints, API keys, and also define the models or temperature for each different thing. And then in code, okay, so in the code I have here my default kernel, where I can give it the lower level abstraction of the check completion service, and then I build the kernel first, and then I can use it actually here. So I give it the system prompt again, so like my rule set, so how should it answer? So like here you are a recipe finder, please give me the recipes. Then my user prompt, which would give it the ingredients. Here's also, so not really support for the templates. So if that's missing as well, we needed to hack that a bit with the string join to get it inside. And then I will just build here the kernel function arguments. And then also for the structured outputs, we also had to define it kind of twice. So once for the prompt execution, and then also to get the prompt back. So one time here, we specify the structured output for the execution. And then again, when we get the results, one time again, gives us more control. So we could, if we want, use like different schemas. But then in the end, I think there was a reason why other frameworks like LangChain4j and Spring AI decided to have both the same for both things. Okay. That's it for the moment, right? Okay. And if we want to go, oh no, first let's compare here the core aspects. So as you have seen, we have very good documentation, LangChain4j. So for me also it was very easy to start. We have very good tutorials even. I also wrote one of them, and they already provide rich enhancement and a lot of features. And I love the fact that they have framework support, not just for Spring, obviously, but also for others. In terms of ease of use, I want to stress out that this is a biased answer, right? It's just our personal opinion, and especially as a Spring developer. So if you know Spring only, it feels like you need somewhat familiarity with how LangChain4j works and how you want to use it, as if I would compare with like Spring where it's always where it should be in terms of the vision of a Spring developer. So how do you see Spring AI here?
Yeah, at the end, it's like, from my perspective, what is a little bit better at Spring AI is really documentation. So it's amazing documentation if you want to see the features and how to use it. Just, I recommend it for all of the Spring project, the official ones. Just open the documentation and read it from page 1 until the end, and then you know everything, what's possible. That's really great. As said, so like the ease of use, also the Spring Boot auto configuration, that's really how you would expect it from a Spring project. The only thing for sure is like it only supports Spring. So if you'd like to use it with other frameworks, etc., that's not possible and will probably also never be possible. You can still, and that you see sometimes, mix and match for specific like classes if you don't use the auto configuration. So like, for example, use some templating capabilities in Semantic Kernel. That's actually possible. But yeah, it's usually, to get the value out of it, you have to or should use the full framework and not just like simple classes that you use or mix and match between those others. How is it about Semantic Kernel?
Yeah, so we support like the main features, right? Everything that is really useful or that is used by enterprise, we do support. And also, yeah. So you can see also the documentation. So I'm a coding person, so for me, code is the documentation. So, but when we work together and others go code documentation first, we saw that it's not as rich as the Spring AI or LangChain4j, even outdated for some time. No, but it is as it is. I want to stress out here, like as a developer, I always want to see competition, right? It's always good for everyone. So the more players we have in the game, the faster they will evolve, the better they will get. So I would like to stress out here that I really like the fact that we already have 3, and with Google Development, Google Agent Development Kit, even another one, which we should also integrate in this presentation soon. Yeah.
This is about basic use of calling prompts, but not RAG support, right?
That will come later.
Right. Oh, wow. Thank you. Thank you. That's a very good transition to the next one. Okay. How do we actually, go with more advanced techniques here, Timo?
Yeah. So actually, it's like
Python.
The technique to really actually improve the responses from the large language models is like fine tuning. So that's really popular. At the end, it's something that requires a lot of resources. So CPUs, GPUs, etc. That means that for special cases and big companies, that's maybe something worth doing. But for a lot of companies, it's just too expensive. Also, like to try out stuff, or just if you just want to integrate some of your data into it. And therefore, there are other techniques to actually add additional context for this prompt to get the answers you would expect or want to get. And the first one, the most simple one, is prompt engineering. So it's like if you put something into ChatGPT and the answer is not like you want to have it, there are a lot of techniques available in research papers, etc., that help you getting the answer in the structure you like it, how you like it, etc. So that's something you could always have a look. And there are, as I said, several techniques like, for example, also chain of thought prompting, etc. But usually it's not enough, especially because of the fact that large language models or foundation models in general, when they came out, they're already outdated because they're only trained from data in the past. So the question is, how can you actually add information like what's the current weather in Netherlands or something like that? That's something you actually have to add to the context. And there are several solutions available. The first one is called tool calling or function calling. And actually what it allows you is to call from the client functions, reaching out to your database, API, etc. And you may ask, okay, what's special about it? I do it all the time in my application. But at the end, the benefit of that is the large language model is deciding whether it should call the tool or needs it for your request, and also providing parameters to this function. And it works in that way that if you enable this tool calling for specific functions in your application, you send metadata with this function. So like what's the name, what's the proposed, what are the parameters to the large language model. Based on your prompt, the large language model will decide whether it should call this function. It will send a response with the parameter values, and then call it on the client side or like the framework, send it back to the large language model with the rest of the context. And with that, it, for example, knows how the weather currently is. So you really have this integration of your APIs, databases in a secure way to the large language model. And why do you have to do that? Because you could also just send your database to it because of the amount of data for sure, but also because of the limit of this context size I already talked about. So like there's a limit of characters, and therefore you actually have to do some work on the client side to only send relevant data to not exceed this limit. There's another way to do it, which is called retrieval augmented generation. At the end, what the benefit, because you can also do the same with tool calling, just call the database and get the information back. The benefit of retrieval augmented generation is, and it's more suited, I would say, for bigger documents, etc., where you really want to have like text search or based on the prompt. And what it does is, without interacting with the large language model or like as it was before, like interacting with it, it will send back a response, etc. You first select data from a data store that is relevant for your context, add it to the context. The important part is the retrieval part, because your request is not like, please give me user with ID, whatever. Your request is like natural language, so somebody has to understand it. And for that, there's also like a flow and additional components, an embedding model, which will convert like this text into a vector. And you have a vector store to save this vector. Okay, why vectors? Because there's something you can run algorithms on called similarity search, which means as a result, you can ask like, what is the recipe I like most with cheese? And that's something you do a similarity search on the database. And if you have recipes with cheese inside, it will return that because of the similarity. And then it's like those vectors, if you know it from school, they are like, okay, 2-dimensional, 3-dimensional, but there's like until unlimited dimensions. So there are thousands of dimensions. And with that, it's possible to have so many different words in this room. And then you can run the similarity on that. And you not only need this retrieval, so like getting for a prompt like the relevant data, which you put in the context, you also need a way to actually transfer your data into the vector database. And that's also something what most of the models actually provide. So like using the embedding model to convert it to a vector and save it in the vector store. And yeah, so also our demo implements it in a really basic usage. Because at the end, it's like you saw before, we have cheese. I can just actually say, use available ingredients. That's a mock of a smart fridge. So there's like a configuration in the Java application, because probably not everybody of you has a smart fridge that can tell you what's inside your fridge. But in our case, it's like a configuration, and there is like by default bacon and onions. And so if I enable it, it will do tool calling, but just return those two answers without, or two ingredients without reaching out somewhere. And if I do that, I should, for example, get a recipe with cheese and bacon. As an example, I think we also already executed here, because the large language models, it takes some time to get the data. Let's see here, for example, cheese and bacon omelette. And the third one, and we have this pipeline where you upload a PDF. A PDF is already part of the Git repository with the German recipes. It will do a retrieval augmented generation. So it will search in the vector store for cheese. And if there are recipes, it will add them to the context, and the large language model will actually, in best case, return this recipe, because we have a prompt that it should use the recipes in the context.
So of course, that's like your business data, right? So in my case, is the family's recipe books of my family's in-laws. So if my mother-in-law comes, I will make sure I have her Käsespätzle and not my favorite potato soup or whatever, Käse noodles or cheese nuggets.
Yeah.
So, okay.
If you go back, you could also see like, this is the answer I just got. So cheese and bacon, stuffed onions. And in best case, so in the PDF, there's like, yeah. Yeah, perfect. So I already get hungry. Yeah. And so the recipe from the PDF is like cheese spätzle muffins, which it was able to find because of the fact that it has cheese, bacon, and onions. So that also worked. And you can also for sure combine them. So that's like here the combination. it will find the same because there are not too many recipes. But the end, it's like, this is how it's implemented. And the UI looks the same for all 3 implementations and also all 3 models, actually. Yeah. Okay, so that's it about the demo. How does actually LangChain4j support implementing to-calling and retrieval augmented generation?
Yeah, so in LangChain4j, we have rich help here. So for instance, on the high-level abstraction, we already can use the add tool annotations. And then it's very easy to just do the function calling or tool calling. I also have it in the code later. And also for RAG, there are a bunch of services that help me to actually do this job of vectorizing, or first split the document. As we said, there is a context limitation. So usually PDFs can get very large. So we have to split the documents even, then do the vectorization of the data, then store them in the vector database, and so on and so forth. And then also to retrieve the data, there's also help here. So it's pretty cool, especially for easy RAG pattern, but also for advanced pattern. LangChain4j has a very, very good integration, as we can see here. So first, I needed to, again, use the libraries or add the dependencies that hadn't been implemented first. And then I can also specify here, for instance, for Redis or also for RAG, I can configure here like maximum resource or score of similarity index as I want. And then in the code, here, for instance, when we define the tool, we can call it. So here it fetches the ingredients and also gives me then back the available ingredients in the fridge. We had to do a little bit of extra work here.
Yeah.
Yeah. Yeah, so as I think we've seen that before for the annotation way, right? So here we have the chat method calling with tools, recipe service, and then we can make use of the user message, system message, and then here do the recipe find function. Pretty simple. For RAG, it looks kind of the same on this case here. We had to specify the content retriever. That one needed to be configured first.
No, the retriever is auto-configured, only the ingester
okay.
has to be configured. Yeah.
Yeah, okay. So let's first start with the ETL pipeline. That makes sense. So we had to configure the ingester here to get that. Okay. And also to do the retrieval here. So it was kind of simple. So first I had to parse the document. Here we're using the Apache PDF box document parser, and then put it into stream, and then basically ingest the data in the embedding store ingester with the document. So that was pretty cool. Splits the text into chunks and does it load to the vector database. And in the end, it looks almost everywhere the same, right? So I have here, when I call the tools, it's like here, and then with RAG, I can just give it the context retriever. Everything else stays the same, and I can even mix and match, right? So I can put as many as I want, also one after behind another. So this one I find very well used or implemented, was very easy to use as a Spring developer.
You can really see the value of auto configuration and those high abstractions. And as always, it's possible to go like on deeper abstractions. If you have more advanced requirements, or want to, for example, configure different or multiple user and system messages.
And since LangChain4j was first, so how much copied Spring AI here?
Copied is the wrong word. So enhanced, I say. No. But at the end, it's like, for sure, we also have contributors that contributed to LangChain4j and now contributing to Spring AI, and therefore there's some influence. And you can see for tool calling, it's very similar. So we have similar annotations. In the code, you didn't see that it's also for sure possible to define or add additional context regarding the parameters you are using, that the large language model is able to understand that. For retrieval augmented generation, because like this flow is always similar. So it's like I have to read the documents, I have to parse them, I have to split them, that the context size will not be exceeded later, and to write it to the database. For that we have support. We have support for vector stores for the embedding models. And then we are using this advisor concept, which I already introduced. So it's like with those advisors, there's a question and answer advisor for naive RAG, so simple ones. And then there is one for more advanced ones where you have, for example, different vector stores and need some routing, etc. If we have a look at the experience, it's also very well supported for sure from the Spring side. So we have those starters, then for example, with the core functionality, then with the different vector stores we're using for the sample Redis, but it shouldn't be, if you want to have a different one, too hard to change that. And then depending on whether you want to read PDF documents or other documents, there are usually specific libraries for that. The next thing we can have a closer look is at like how to use that. Let's first do tool calling. Just checking. So as you can see, here's my annotation. That's the tool. And then from a calling perspective, I just in my chat client add the .tools. In this case, this, because as before LangJ4j, it's just an instance of an object having this method with the tool annotation or multiple ones. And therefore, because I have this tool annotation here, I just specify, this instance. And as you may know, if I have like those beans in Spring with the @service annotation, so those stereotype annotations, they're singletons. So therefore, if I have this, it's one instance. And actually then my framework knows which instance it has to call to actually call then this tool functionality. From retrieval augmented generation, we also have this pipeline reading PDF documents in this case, but also a lot of other documents with the libraries. Then splitting it for the context size and then also storing it. And from usage perspective, it's also very similar. So we have this question answer advisor, as I mentioned, so the naive RAG, and we configure some capabilities like how many results we'd like to have, the similarity threshold, to actually ensure that it's really like including cheese in our example and not like returning any recipes that are not that similar. And then we use this advisor and just configure it with .advisors. And with that, we have retrieval augmented generation. So all the flow like reaching out to the database, doing similarity search, using this data, adding it to the context, etc. Okay, so that's it for Spring AI. Semantic kernel.
Well, so the tool calling is not bad implemented. So here we can also just use the defined kernel function and then do the tool calling. That was pretty well integrated. For the rec part, you can already see it's kind of empty. So it's also using the Apache PDF box. But we really had to do a lot of more by hand. And yeah, so the code is online. I think in the matter of time, we want to skip the demo here. So just for reference, tool calling was fine. Rec was kind of complicated, so not a lot of help here from the framework.
Yeah, but feel free to have a look at the source code and try to understand it.
Yeah.
Okay, so there's one more thing. Before we have a look at like the table comparing all of three frameworks, there's agentic AI. So in the past is like, the last few months, years, whatever. It was more like on the left. So at the end, it's like you have a client, so an application, making the decisions whether to actually get the data from a database, adjusting or improving the context with the data, like with retrieval augmented generation, and reaching out to the large language model based on the context. The large language model returned the result or the response. Agentic AI is putting the large language model like in the center, because it's like the large language model is making the decision. So whether to reach out to a database to get the information, to another application, to another large language model. So it's a lot more autonomous than before. Important is it's not like the interaction, because it's really based also on tool calling. So it will always go back to the application, like, please call me this database, etc. So you don't have to attach your private database to a large language model. It's still like one application doing like all this interaction. It's more like who is making the decision to call something. And for these agentic applications, actually, there's one problem. So if I have all those tools, and you cannot imagine about, okay, I have my database and I have my API that is implemented by me. It's a lot more like all those different enterprise tools that are using. You can for sure implement all this stuff yourself, and that the large language model is able to understand that. But actually, it's like that's something solved by the so-called model context protocol, which is an open protocol that is in a way standardizing the way how the large language model communicates with different tools, databases, etc. The big benefit of that is that all the vendors where you buy software from, they can and already start to provide model context protocol compatible servers, which you can integrate, for example, in Cloud Desktop, etc. So in your tools, without having to implement like the API for that. And then a large language model is directly able to interact with them. So that's really impressive. We should see demos of that. And that's something we also have support for. So actually the developers working on Spring AI, they actually implemented the first version of the Java SDK for Model Context Protocol. And this is also one of the reasons we are a little bit ahead of like the competition. Even if I wouldn't call it competition, because of the fact that we implemented the SDK. This is why we also, for example, support the server side, not only the client side, and those other frameworks that just have to keep up to also support both. But yeah, here's our comparison. How do you think about LangJ4j?
Oh, well, yeah. So as we've seen, very nice tool work, seamless integration, very easy to use. For MCP, I'm very happy that it was framework agnostic wise integrated into the MCP protocol. So everyone can use it now. We can also build our own clients. And I guess you've seen already LangJ4j clients being built. So I feel that they're very good on this side. Okay, Spring AI, everything green, all good. Semantic Kernel for Java, well, there are a few things missing, but the main parts are here as well. So competition-wise, I'm kind of happy.
Yeah, and regarding like demos, actually also like in this Git repository we will share in a minute. There's also a link to an implementation of Spring AI and MCP. So if you want to have a closer look, as that, so MCP is a lot about integrating a lot of different APIs from vendors, but this sample shows how to implement it like from a Spring perspective. So you shouldn't, or not every service you provide should now be implemented in like MCP as an MPC server, only if it really makes sense. But this is really a sample how to implement it, so just as a note. Okay, and yeah, so we're finally at the summary. Great.
Yeah, I don't need to learn Python. I can stay with my favorite language, and I also don't have to train all the backend developers. We can all stay in Java, make use of AI, use it in production already. So I think we didn't say it, but all three are GA, so they're ready to be used, and we can go for it. Yeah.
Yeah, and here it's like it's so as you know the AI world standards, whatever models, it's moving so fast. You should always like have a look what's the current state and what's coming up to actually make the decision what works best for you. So also from a framework perspective, etc. Even if it's like currently a semantic kernel has to improve a little bit, it could be that in 1 year it's different. Yeah, always like have a look at the news and what's out and what's changed. Yeah, that's my recommendation.
Yeah, and with that, thank you very much. So here's the QR code linking to the GitHub repository. In the very first top of the README, you can find all 3 or 4 repositories if I count the MCP in. And with that, we do have a little bit of time for questions, so I can take like 2. If there is a question. Yes?
One thing that's very complicated for me as a developer is like, okay, the AI service, the tools, assistants and stuff, okay. But then when it comes to advanced RAG, you get instructions saying, well, you need to keep in mind that the embedding in the vector is compatible with the retriever.
Okay.
Yeah. How do I keep that in mind? Is there any help from the framework telling me which are compatible embedders and retrievers?
Interesting question. So just as a recap for the recording, you said the fundamentals. So what we have shown is super easy. But for the advanced stuff, like advanced RAG, it's getting more complicated. And if there's more documentation, more examples, more tutorial.
Yeah, or maybe even some compile level help or framework level help saying use these or these are.
Yeah, so actually it's like also like if you configure the dimensions, etc. The idea usually is like as you said, it's easy if you have one application or like the same source code base, because then you have the defaults, you configure the defaults, and with that, everything works in a way well. The problem is if like you have different embedding models, maybe you have different configuration for the dimensions, for the vector store, or even different vector stores. That's a little bit challenging. But there, I think, yeah, the only way you can do it if you have, for example, multiple applications for multiple purposes is to find a way to standardize like the configuration that you have and also like the databases. Because, yeah, this has to match the configuration in a way. And for sure, if you have multiple applications, you need a way to find this consensus on what is the number of dimensions we are using, etc. So does it answer your question a little bit? So it's like, I think with the beans and the abstraction, it's possible. It's a lot easier to do that. But yeah, you still have to figure it out yourself across different teams, etc. How you standardize on or have the right configurations for all those different capabilities. Yeah.
Okay, and with that, you can find us here. We will be at the conference because the recording team is saying we are out of time. Thank you so much. You've been a wonderful audience.